In this video, we will solve a homogeneous differential equation using the method of undetermined coefficients, where my function of x will be a multiple of a polynomial, a trigonometric, and an exponential part. Here is the trial yp of my equation, my function of x, and here's my question. So with this question, first of all, find the general solution. General solution is found here by the general methods that are first find the roots and then place them. Then I have to figure out my yp trial. So the yp trial in this case is this complete equation where these two bracketed polynomials have the order 1, since my order here is 1. So after identifying my yp, I opened my yp and then I differentiated my yp to make a yp prime. This was differentiated, each term is differentiated using the product rule, and you can see this very long equation. I have to again differentiate this equation for making my yp prime, double prime. This is my yp double prime, where I use the product rule again. I applied the product rule again on each and every term of the yp prime. And you can see there are few terms where I have not differentiated the values. I have kept them as it is, but later on I differentiated them and put them in the right places, substituted them, and here are my simplified versions of my yp prime and y double p prime. Here is the equation, the question, which says that y double p prime is multiplied by 1, whereas y prime is multiplied by 2, and y is as it is. So I have written all the values of y double p prime as in the order. But one more thing, I have also separated my sine 3x from the other terms. Sine 3x terms are on one hand side, from the sine 3x terms are on the one hand side, you can see, and note all the coefficients, the bracketed part. Here is my 2ax plus a naught. Here this follows here, and from here, from this bracket, you can see that yp prime has been doubled, because in the equation you can see that the 2 was being multiplied to this term. Now making my equation 1. What I did in the equation 1 is, first of all, I equated all the coefficients of sine 3x into e to the power 2x to the coefficients which were given in the question. And after this, I equated all the coefficients of x in this equation, and then I found out one value of one constant, that's a naught, and then I made another equation using the constants in the bracket of both the sides, and I equated them, and here is one solution for equations 3 and 4. First of all, I separated all the cos 3x values this time, remembering that I have to multiply my y prime by 2, so these values are the multiplied values of y prime. And then again the same step, I equated all the coefficients of x, which I have underlined here, to the coefficient of x in the question. That was the assumed 0x, and then I figured out my b naught value, that was 0. Then for equation 4, again the constants of the right hand side, the constant of the right hand side were equated to the constant on the left hand side in the bracket, and this gave me the values of b1 and a1. Then after getting all the values of a1, b1, b0, a0, I substituted those values, and then after substituting I got my yp. This is my yp. I'll add this into the yc as here, and this will become my whole solution.